Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at an implicit differentiation question, and we want to find the derivative of y with respect to x, and then we want to evaluate that derivative at the point 2, 0. Now again, if they only gave us this 2 here for the x value, we could put that in here and we could solve for y. But they were nice enough to give us both coordinates there. So let's see how we would go about doing this. What we're going to do is we have three terms. The 32e to the y is one term, x to the fifth is another, and y cubed is another. Our strategy here is to take the derivative of each one of those. But if we take a derivative of a dependent variable, in this case y, then we need to use the chain rule and then also multiply by the derivative of y. So let's go about doing this here. So 32e to the y, well, we can use the constant multiple rule, just leave that 32 there. And then e to the y. E to something, the derivative is just e to that same thing times the derivative of that thing. And that thing we're talking about is the exponent y. So we're going to start with 32 e to the y, e to the y. And then we're going to multiply by the derivative of that exponent, because that's the inside function there. So we'll just call that y prime. Another way to look at it is every time we take the derivative of a non-independent variable, we also have to multiply by the derivative of that non-independent variable. All right, so this is equal to, we're differentiating x to the fifth with respect to x, so we need to just take the derivative as normal, applying the power rule. You just get 5x to the fourth. And then we have y cubed. Again, that's not our independent variable. So we're going to need to still apply the derivative of the outside function, which is 3y squared, times the derivative of the inside function, which again is just y prime. All right, let me thicken this up a little bit if I can. Call it. There we go. Let's see, how's that? That's much better. All right, so now what we're going to do is we're going to group each term that has a y prime in it on one side. So the first term here has a y prime in it, so we're going to keep that on the left. This term over here has a y prime in it, so we're going to subtract that term from both sides. So we're going to have minus 3y squared times y prime. Let me make that y prime a little clearer there. And then this is going to equals, and since 5x to the fourth does not have a y prime on it, we're going to keep it on the right side of the equal sign. So 5x to the fourth. Okay, what that lets us do is it lets us factor out a y prime from the first two terms. So if you divide a y prime out of this first term, you're just going to get 32e to the y. And if you divide out a y prime from this term, you're going to get 3y squared. And again, this is all equal to 5x to the fourth. And let me give myself a little bit more room here. All right. And then finally, well, at least to finish off the equation of the derivative function, we're going to divide by this factor here. So we're going to have y prime is equal to 5x to the fourth all over 32 oops, I said 32 and I did not write it. 32 e to the y minus 3y squared. 3y squared. Alright, so that is the derivative function. We notice we have both x's and y's in here, which is why we need both the x and the y coordinate. So let's go back and take a look. That's at the point 2, 0. So that means that my x is equal to 2 and my y is equal to 0. Alright, so if I look at my derivative function, which we can also call it, instead of y prime, f prime of 2, 0, something like this. You'll see it written in a couple of different ways, but that just means that I'm going to plug in a 2 for x and a 0 for y. So this is going to be x squared, or x to the 4th. That's 2 to the 4th, and 2 times 2 times 2 times 2 is 16. 16 times 5 is 80, so we should get an 80 on top here. And down here, e to the 0 is just 1. So 32, and this is going to 0 out over here once we plug the 0 in, so we should just get 32 on the bottom. Let's see, this is 40 over 16, 20 over 8, 10 over 4, 5 over 2. Is that right? Let's see, 5 over 2. Yes, because if you divide 80 by 16, you get 5, and if you divide 32 by 16, you get 2. So, going back up here, that's what it is. So this is the slope of our tangent line at the point 2, 0. If you have any questions, please let me know, and I hope you have a great rest of your day.